Due to the lack of knowledge of the tool, many participants make the design a slave of limited knowledge of the tool. When you design using your hand and probably on a piece of paper, the mind and the paper connection is very, very strong. Whereas when whatever you think is laid down directly onto the piece of paper using your head, when you suffer in terms of the lack of knowledge, the design is not what you expected, right? In terms of what it could have been, because you didn't know how to use the tool. So it's a two-edged sword.
So today, I have the pleasure of talking with you, Kanwal, and let me introduce you first. Okay, so Kanwaljeet is an architect and a computational designer from School of Planning and Architecture, Delhi. With experience in firms like Studio Space Matter and ORproject, he has delivered large-scale projects like the Bahai Temple that involved research, conceptualization, and digital fabrication using computational design methods. Okay, hi Kamal. How are you
Hello.
today?
I'm good. I'm good. I'm very well.
Okay, can you introduce yourself? Tell us what your role currently is and your responsibilities, like as you know what you do.
Okay, so first off, thank you for the wonderful introduction. And pretty much what you have said is in relevance to what my professional experience has been. But currently now I'm working as a consultant in the computational design field, where I try and help different firms and practices to solve their design problems efficiently, whether it comes to forms or getting efficient output in terms of design, whether it's in relevance to sustainable designs or fabrication or execution at site. All those things that I can help with computational means, I try and solve those problems through computation. And that's been my journey for last 2 years now.
I see. That's wonderful. Okay, so let us start off with our interview officially. So first thing first, can you tell us what computational design really is, and how did you first come to know about it?
Okay. So to understand what computational design is, I would say we should first understand the difference between computerization and computation. So fundamentally, the basic difference lies in the approach towards design rather than the particular skill set of the knowledge, right? So if I talk about computerization first, this is a computer-aided approach or some may consider it as a digital design. As stated in the book Computational Design Thinking by Akim Menges and Sean Elquist, a computer-aided design or a computer-aided approach assumes an object-based strategy for expressing the essential information into symbolic representation. To simplify this, consider a primitive tool in the design field like AutoCAD and SketchUp, which are very dominantly used across the architectural industry, right? These tools are just means with which a user can digitally store his design, and probably it can prove to be a efficient mode in terms of saving time. The user is basically setting and working around with the rules internally in his head, and then rather than putting it on a piece of paper, it is compiled on a computer system, right? This process of design is already conceptualized in the user's mind and is compiled and manipulated in a computer system. It does not enhance the knowledge and the understanding of the process that the user is trying to define. So, the design problem with this situation is that designers do not take full advantage of the computational power of the computer. Whereas, when it comes to computation, if I try and term this, it is processing of information algorithmically. What does an algorithm mean? A set of procedures consisting of a finite number of rules which define a succession of operations for the solution of a given problem. Like, this is the technical information or the definition that would come for algorithm. Well, an algorithm is a finite sequence of explicit elementary instructions that is given by the user in an exact, complete, yet general manner. So to simplify this, computational design is a use of computation to develop design and design systems. We as a human have a very limited capability to compute and process information, right? When it comes to solving complex problems, designs, and processes, a computer is far more efficient than a human to not only solve it, but also to manage multiple and simultaneously occurring tasks without any error. By using computation in design processes, one can draw a logical conclusion from values, rules, and algorithms that define the design process. We can increase the amount of specificity of information that is initially supplied using algorithms, as stated in the book Computational Design Thinking. So in contrast to computerization, which helps us to replicate laborious tasks like hand drafting on a computer system, making it less time consuming for us. Computational design is not only efficient means to solve complex design problems, but it also enables us to design systems that can solve complex problems. So in contrast, these are the two terms, computerization and computation.
Okay, so that's I think we can understand it as a field that is just so broad because of the capacity, because it just depends on the capacity of the computer. Yeah. And I'd say, many young architects and designers are confused between the terms computational design and parametric design. Can you help us differentiate between the two?
Well, this is a very debatable topic, and different people have come up with different, conclusions towards these. And not only computation and parametric design are the terms that you usually hear. There are other terms like algorithmic design and generative design, which are closely associated with computational design. So if I were to explain it in my terms of understanding of these concepts, the term parametric design, algorithmic design, and generative design are all encompassed under computational design. One can consider them varying use of computation in design processes. So to first talk about parametric design, the term parametric is about relating to or expressed in terms of parameters. If there are parameters which are interrelatable, then that makes it parametric. Let's consider a mathematical function where, if you would have learned mathematics in your school days, you would have come across the function where fx is equals to, let's say, y plus z, right? Here, x, y, and z are the variables in a function which are defined algorithmically in a parametrically established relationship. Here, the relationship is as such: y and z, when summed together, gives us a value of x, where the x will be dependent on the relationship between y and z, right? So this nature of parametrical nature, when it comes to, let's say, equations or numbers, or whether it comes to geometry, where we do architectural design in terms of geometry to find, probably efficient solutions. This nature of being linked in a relationship parametrically is called parametric design as such. When it comes to algorithmic design, a design process which is based on algorithms. Now, algorithmic and parametric design, when used in design field, are kind of like very interrelated. They cannot probably be, may or may not be individually termed as such in terms of its use. So an algorithm is a set of mathematical instructions or rules that will help calculate an answer to a problem. What does that mean? For example, there is a very famous game of life by John Conway, where a set of rules are defined by the user at the very beginning, and maybe we do not get to anticipate the end outcome. And these rules are the governing factor which run recursively until a certain condition is met, where the algorithm stops, right? Here, the rules that are set in the beginning define the algorithm, which governs the outcome. The user may or may not know the final outcome, but what is known to the user is the algorithm deriving the final outcome. These may or may not include loops, conditionals, and in terms of designing the algorithms, which can help us solve complex problem if used for in terms of algorithmic design. Now, this brings me to the last point of generative design. In generative design approaches, after starting the generative process, the system executes encoded instructions, and until the criteria is set or is met, till the final outcome is achieved. In any case, the algorithm is difficult to correlate with the general output, thus making the outcome difficult to predict by merely reading the algorithmic descriptions that the user has set in the beginning. Now, there is another term that comes in relation to generative design, which is not different from it. It's kind of like an extension to this, which is called the performance-based generative design systems. These are good examples where we can relate to generative design. For example, when we talk about sustainable design, we think in terms of energy efficient building, or maybe there is an efficiency in daylight within the internal spaces of the rooms. Now, these efficiencies are met under a certain condition based on a certain algorithm, which, when analyzed and compared between the variants, gives us an efficient output. In this, we as a user are setting a performance target which we want to achieve, and an algorithm finds the best solution, or probably the efficient solution that best approximates the desired goals. Right? So these are the 3 points that which are termed under computational design. By means of using computational powers or the power of computation, we can get into probably define these 3 terms separately.
Okay, thank you for explaining to us about these all 3 terms that comes under computational design. You are currently working as a consultant, right? So can you tell us more about your professional journey up to this point?
Well, I initially, as you have stated in the beginning, that I started off to use computational tools in solving problems at an office which I was initially working on, whether it comes to competition-based projects or real-life projects. In the process, I kind of learned how to use the tool and try and apply it for the real-life design problems, which has helped me shape and build my foundation over which I could continue to learn. At that point of time, I was only using the parametrical nature of the tool to make things more efficient, and probably maybe to some extent to use generative design to get the efficient solution. Then later on, I moved to ORproject, where which is a computational design firm. It is oriented towards that, right? So in that, I learned that computational tools are not mere efficiency-oriented tools, which allows you to do things parametrically, but also to go beyond that and solve complex problems which occur in real life, or probably can have an impact on real life projects, right? And then later on, after when I've completed my working period at those offices, I started my own consultancy, where I try to solve design problems of different scales for different projects in different firms across the country, and probably some projects internationally. This has helped me understand where the problem lies in terms of what user needs and how a computational tools can get them not only solve the problem efficiently, but also give them an informed decision to get to a final outcome, and that proving that to be the right solution, right? Whether it comes to designing things, whether it comes to fabrication and execution at site, whether it comes to managing complex designs or complexity of varying elements, computation has helped me and helped me to help other consultants. Computation has helped me to help other firms to do things more efficiently and accurately.
So that has been your professional journey. But how did you start learning computational design? You know, it's such a broad field. Were there any
Yeah.
challenges you faced?
Well, as I mentioned, I initially started my journey into learning the rules of computational tools, like how the tool works. For example, Grasshopper and Rhino, which has helped me create a foundation onto how the tool works and what are the rules, so that I could then take on my ideas and try and replicate them. So once I got handy in terms of using the tools, I then started leveling up in terms of learning from, let's say, books or whatever that the resources are available online with the mentors that I have been under, to which has helped me guide into being who I am today. And this has, all in all, helped me create a foundation over which I could not be stuck with using the tool for the sake of it, but also to probably relate it to real life problems where I could solve the problems more efficiently using computational tools. Now, when it comes to challenges, the initial challenge was to, probably get started, which I see in most of the students that I have come across before joining the course. So, what it feels like for an outsider when I was in college, when I was not using computational tools as such, it felt really intimidating to, when we are as an architect or a designer, our approach towards design is very intuitive and visual. Whereas visual scripting seems to be organization of those spaghetti-like components which are running with all those wires. It felt very intimidating. But once you get the gist of what is happening there, and once you realize the power of computational means through these tools, you then tend to not go back in the loop, and you feel like, why is the other tools not so efficient like this and capable of going beyond the efficiency and probably help us solve complex problems as such.
Okay. Then how did you land your first project? Can you tell us more about it? Your first computation design project?
So it was basically about me putting across my word on online platforms, and through the word of mouth and through 1:X, I got to be in the domain of professional, and people got to know me. And so there was a requirement in a firm where they needed to get efficiently fabricate some of their complex designs, which otherwise would not have been possible using a primitive tool. So they knew that I am the person to approach, and by getting to know what the problem really is and whatever I could contribute through my knowledge, the firm realized that this would be the best way to go about it, and then we got into doing the project and executing it.
So now you have, I would say, a substantial years of experience working in this field. So in your opinion, what is the future scope of computational design in the field of architecture? Will it be a lucrative field?
Well, I cannot be definitive about the answer towards this, but what I can come to conclusion is that efficiency in workflow has always played a vital role in adaptation for new methods within any field, whether it comes to architecture, design, or whether it comes to like AEC industry or whatever. When it comes to computational design, maybe the learning curve for many would not be that easy and intuitive as what the traditional softwares or tools allow us to do, right? That is something that has been adapted by masses today, right? Because a majority of designers are very visual and intuitive in nature, maybe that is the reason it is currently not as adapted as widely by the masses today. But let's consider in the future, maybe because of AI, a user can achieve the desired goals by not only getting into codes or visual scripting, maybe the way we see and use computational mode of designing today would become redundant. Like I've come across some of the ways in which an AI can generate images just by providing in text, which may not be as accurate as a designed product or a project, but it can get us into get us into a peak of the future, how AI is going to be very, very user friendly, where you might not have to be worried about what happens at the back end. At that time, maybe the computational design would be more widely adopted. But then it also brings back to lack of control over your design. So there would surely be people who will be using computational design till its step where they are strictly coding something in programming language like Java, C Sharp, or Python, or using visual scripting. But then the widely used masses would prefer not to get into coding, and hence AI would come in to solve their problems without using tools.
So you did mention about some, I would say, setbacks of or the hesitation of masters to take up this field. So we know that everything has its pros and cons. So how about the computational design field? And what should young architects be mindful of before setting off on their computational design journey?
I think the main problem that I've seen by teaching participants is that it's not the lack of knowledge that the participants, occur that they face as a problem. The problem lies in the thinking. How do they think algorithmically? How do they try and frame the problem and then find a solution? That is one of the problems. The other thing is that due to the lack of knowledge of the tool, many participants make their design a slave of limited knowledge of the tool. What I mean by that, when you design using your hand and probably on a piece of paper, the mind and the paper connection is very, very strong. Whereas when whatever you think is laid down directly onto the piece of paper using your head, when you suffer in terms of the lack of knowledge, the design is not what you expected, right? In this process, you try to negotiate between what you know and what is possible, and then your design is underdone, I would say, in terms of what it could have been, because you didn't know how to use the tool. So it's a two-edged sword. If you know it well, it will work fine for you. If you don't know it well, of how to use it rightly, then it can backfire and it can create a very mundane designs, which I see happening a lot in terms of the final capstone project that we do in Oneistox course.
Then what would you say are the necessary hard and soft skills to work in the computational design field?
Well, for beginners, I would recommend learning the rules of visual scripting would play a vital role in establishing a good foundation, given that a person is working in coherence with algorithmic thinking to develop good logical reasoning skills, right? But that is not all. It is the first step probably, because the main challenge does not lie in mastering computational design techniques, but rather to fully understand a mode of computational design thinking. So in this, people do not usually lack the ability to use the tool. What they lack basically is how to use, what to use at what given time to solve a given problem, right? So this is going to be one of the challenges that people would face, and they would have to work around this, not only to just learn the tool, but also to logically reason things and thinking algorithmically or computationally to solve a given problem.
Thank you. That sounds like a really helpful advice. So what softwares do you use on a regular basis? You did mention Rhino and Grasshopper. Do you have
Yeah.
any favorites?
Well, I do use Rhino and Grasshopper very frequently. AutoCAD is one of a mere tool to just produce working drawings or probably fabrication drawings after when I'm done with Rhino and Grasshopper. For physical simulations, I prefer going for Cinema 4D, uh, which in itself is a very vast tool to cover itself. So yeah, these are the two. Whereas Blender is an open source software that I would recommend for early learners if they want to extend their arsenal in terms of using the tools.
Mhm. Then what software would you suggest for a beginner?
I would say start with Rhino because once you learn, well, my engagement with Rhino was as such. I used to use AutoCAD, SketchUp, and all that in initial days of my college, right? Once I started using Rhino, it was more like AutoCAD, but a better version. Like there are a few things that are very irritating in AutoCAD, and probably you would expect that AutoCAD might release a better solution for that. Rhino already has addressed those problems. And one of the example that comes to my head is that in AutoCAD, you can scale the geometry all in three axes simultaneously. Like it's a very general thing that anyone can relate to. If you would have wanted to extend something in one direction, you would have to do stretch or all that. But in Rhino, other than stretch, you can also do scale 1D, scale in 2 dimension, and scale in third dimension. And all those is possible. It's very elaborately um, worked around to help solve real life problems that occur in using a tool. And the vastness of addressing problems in this tool is something that I would say that recommend for people to use.
Thank you. You
When it okay,
please
sorry.
continue, please.
When it comes to choosing the right tool, you should also be aware of what the tool is capable of providing. When it comes to mesh modeling, maybe you can use Cinema 4D or Blender. Or when it comes to physical simulation or animation, I would prefer those softwares where it's not too subjective about creating a design and then fabricating it efficiently on site or probably creating a product out of it. Rhino has a very, very strong base to provide very efficient solution towards not just creating the design, but also fabricating it when it combines with Grasshopper for even a complex design problem. So what software should one use should be dependent on what is the need for them to use that particular software.
Yeah, that's very true. You did mention, Oneistox and that you have been mentoring for our parametric modeling course. So, why would you recommend Oneistox parametric modeling course to learners who are interested in this field? And how has your experience been so far as a course mentor?
Okay, so I'll answer the first question first. So, why would I recommend Oneistox parametric modeling course? The first reason is that we are starting off. The first reason is that we are starting it off at a very fundamental, basic stage where a primitive knowledge is not expected from students other than what they already learned in architecture or design school, right? So it starts off from a very basic level where anyone can start off, whereas the pace at which people can practice, right? It is something where students can take their limited time after the college or professional work field that they come back to their home and spend 1 or 2 hours every day for 3-4 days in a week and get along with the course in the scheduled manner so that they can grow, not only to just trace out what has been taught in the in the course, but also to question what they have learned and how they can expand their knowledge by connecting with the mentors and the team across. So these are the two reasons that I would recommend the course at Oneistox. Now, how has my experience been so far? I think it's been wonderful. It has not only helped me teach various students simultaneously and probably share my knowledge, but it has also given me an insight of how people start to learn and what are the problems that they face when it comes to using the tool and trying to solve design problems. And the process that I've come across is that the problems that I've come across is that people are not only limited by the knowledge of the tool very initially, but they are also limited in terms of using computational means of thinking or the algorithmic thinking, which for some comes very intuitively to probably expand on the variations that would occur in terms of trying to solve a design problem. Which one of the particulars would you choose to go about it, right? So I would say it's been a very wonderful experience as a mentor to teach and to learn as well.
Thank you. Glad to hear that. So we're now at our final question, actually. What advice would you give to young graduates out there who are interested in this niche?
Okay, so what I've seen out there for college students or young professionals is that they try and get into learning computational design or the tool just because masses are doing it, right? Regardless of what they intend to do with it. That is something that needs to be decided. Do not learn a tool just because the masses are learning. For example, computational tools or the BIM tool. Your end target should be defined from the point of view where how would this tool help you do what you want to do, right? Otherwise, you will end up feeling lost without any direction. It's like learning how to, probably use the knife, but you don't know where would you use the knife. Would it be used to probably for vegetables or something that you want to cut, or rather you would just try and hit it on the wall and then it might not help you. So maybe the right tool should be used given that the problem that you're trying to solve can be solved efficiently and sensibly using that. So, at a conclusion, I would say first understand what is it that you want to do, and if computational means are a good decision to follow up on that, then probably you can go and start your journey in computational design.
Thank you so much for the advice. It's I'm sure it's something that all those who are interested in this niche needs to understand. Don't just start learning because other people are doing it. Thank you so much for this lovely conversation, Kanwal. It has been really great talking to you. Even I myself learned more about computational design and parametric design. Thank you so much again. Have a wonderful day.
You're welcome.